All right, so this is a second method for simplifying complex fractions. There's another video that I made that has one method that a lot of teachers use as far as to help you with factoring, but this is another method that you could use for simplifying complex fractions. Okay, so complex fraction, just like the other video, fraction means you have a number over another number. Basically, a division sign means a fraction. Complex means it makes it more complex. So moving through. It's because I'm making these back to back, so taking up a lot of time. Definition: a complex fraction is a fraction that contains a fraction in its numerator and or denominator. So, look like that. Okay. We have a fraction bar. We have a fraction inside the numerator. Actually, we have two of them, but that doesn't matter as long as you have one. And we have a fraction in the denominator. Now, you don't need it in both spots to be considered complex. If you have a fraction and you have another fraction somewhere else, then that's considered complex. So it's a fraction made up of another fraction or two or three or four. So that's the definition of that. Simplest form. So we have this fraction within fractions. So to make it in simplest form, you want to make this weird fraction with a bunch of fractions into one fraction altogether. So we're going to simplify it. Now, simplifying doesn't mean you change the value. Simplifying just means you change the way it looks. It's still going to have the same value. So if you plug this into the calculator, and then we do the simplification process, and we get a different looking fraction, if you plug that into a calculator, you're actually going to get the same number. Okay, so we're just changing the way it looks. That's what simplest form basically means. Now, the way to put it in simplest form is to write it as a single fraction, and make sure that once it's written as a single fraction, that all common factors of the numerator and denominators have been canceled. Final answers need to be written in whatever form your teacher wants you to write it in, either factored form or standard form. Factored form means it still has a bunch of parentheses all over the place, so that's kind of like a quick way of explaining that. All right, so I'm going to show you guys the method using this simple, or not that simple, but simpler example. This method is called the LCD method. So if you watch the other video, it was working in separate parts the whole time. This one, you're actually going to be working with the numerator and denominator at the same time. So I'm not going to use so many colors this time. So that's your numerator. This is your denominator. So don't worry about all those little fraction bars all over the place. Just think of the numerator and think of the denominator. So the way that works is this. I'm going to leave myself a little bit of room here. So this is 4/3 plus 8/3. And I'll put my parentheses a little bit far out. That way I have room, divided by, and then 2/5. Now, what I want to do here is I want to take into account the entire expression here and then look at all of my denominators. So my denominators are a 5, a 3, and another 3. So basically what you can do to find the LCD is factor the bottom parts and then write out the list of all the factors. Now these are all prime factors anyways. So my factors on the bottom are a 3, another 3, and a 5. Since they don't break apart, that's all they are. Now I don't want to double list something twice. So I have a 3, I have another 3, I don't care about that. I already know that my LCD has a 3. So best way to do this, start building your LCD by making your list. So I have a 3. Now I have another 3, but I don't care about that. So my other number is a 5. So 3 times 5 is basically my LCD. Now I'm not going to multiply that to be a 15. I'm going to leave it a 3 times a 5. So I'm going to multiply this side by a 3 times a 5. And I'm going to multiply this side by a 3 times a 5. I'll go ahead and put that in a little group. Okay, so on the left-hand side, or the numerator side, this is your numerator. Remember our division sign right here? I rewrote it as a division sign here, just like the old school way of dividing. So what I'm going to do is I'm going to take this 3/5 and multiply it into both of these terms right here. So I'm going to take the 3/5 and multiply it to this one and to this one. So what's going to happen in the first case is you're taking 3/5 times 4/3. What's going to happen is the 3's are going to cancel. You're just going to end up with a 5 times a 4. I'll show that over here in blue. This is just some side work. So if I take a 3 times a 5 and then multiply that by a 4/3, if you think about this, is top times top and bottom times bottom. So I get 3 times 5 times 4 over 3 times 1 is a 3. those go away, you get 5/4. I'm sorry, 5 times 4. So, yeah, I'll do this side. So 3 times 5 times 4/3 is just going to turn to 5 times 4. Plus, now 3 times 5 times 8 divided by 3. So once you get better at this, you'll just see that the 3 here and the 3 here will go away. You're just left with 5 times 8. Okay, that's still my numerator. Divided by, now I got to multiply this times here. So that's top times top, 2 times 3 times 5 divided by a 5. 5s are gone. So 3 times 5 times 2 divided by 5 is just a 2 times a 3. Clean this up a little bit. Well, these are just integers, so we can actually do this out. 5 times 4 is a 20. 5 times 8 is a 40. Divided by 2 times 3 is a 6. That's going to be 60 divided by 6, which is a 10. Okay, so if you watch the other video, it's a little bit different than doing this way. This way, you're multiplying everything by the LCD, so stuff cancels out. My other classes, I call this a fraction buster. But yeah, you're allowed to do that. So, and then that's it. Okay, so let's try this one. On this one, same thing. We got a numerator and we have a denominator. So we're going to rewrite this, leave some room so you can work. So 2 over x plus 2. Actually, these ones you don't have to leave yourself room. I lied. Haha. Because you're not working on the inside. So divided by the numerator, denominator, which is 1 over x plus 2 plus 2 over x. Okay. So basically what you're going to do here is multiply everything out by the LCD. So the LCD, like I said before, make sure everything is factored first off. So this x plus 2 over here, you can't factor that, so that's just an x plus 2. Same thing here, x plus 2 isn't factorable, it's just an x plus 2. So I usually tell my students, when you can't factor it, make it a group. X isn't a group because it's just one term, so you don't have to group it because it's already one term. The whole point of grouping something is to make it into one term. So if I think about this, I have a x plus 2, another x plus 2 is a factor, and another x. So building my LCD, I have an x plus 2, and I have an x. I can write it like that. And that's it. I have 2x plus 2, so I don't got to write it twice. So I'm going to multiply both sides by x plus 2 times x. So I'll rewrite it like this, x plus 2. And this side, x plus 2. All right, so when you multiply this times this, you will get the x plus 2's canceling out. And you'll end up with a 2x. Now when you multiply this and this, the x plus 2 parts will cancel, and you'll get 1 times x, which is just an x. When you multiply this times this, the x parts will cancel out, quote unquote cancel out. So plus 2 times x plus 2. Now keep in mind this entire thing is still your denominator. This whole thing is still your numerator. So you got to distribute again. You'll end up with x plus 2x plus 2, which will become 3x plus 2. This 2x stayed the same the whole time. Okay. That was the bottom the whole time. So now you just have 2x divided by 3x plus 2. That's it. Nothing factors out, so make sure that if you can factor something, factor it to see if it's a 1 equivalent with something on the top. All right. So yeah, this is another method that you could use to do this. And oh, sorry. And I don't know why I said sorry. Those of you who had my class, what you're actually doing here. So hold on a second. Whoa, that was weird. Okay, let's try this again. Okay, there we go. Let me shrink this down. What we're actually doing here, with my classes, I always teach the fancy ones. So when you multiply out by the LCD, like hopefully some of you guys are thinking, well, how are you able to just multiply both of those by an x times x plus 2? I mean, that's, you just decided to do that. The reason why is because this stuff over here, that's numerator and denominator stuff. So thinking back to this beginning fraction, what we're actually doing is we're multiplying the top and the bottom over here by by the LCD, and that's a fancy one. So you're actually multiplying it by a fancy one made up of the LCDs. Okay, that's the reasoning behind that. Just in case you're wondering, and you probably weren't, but I like to explain stuff out. So same thing here. If you'd like to do it without splitting it apart like I've been doing, I'm just used to splitting it apart like I do. You can do that also. So I'll show this one both ways. If you just want to see it one way, then that's fine. But I'm going to show it both ways. So you can, it's a video, you can stop it if you want to. We got a 2 divided by x minus a 3 divided by a 1 minus a 1 over x minus 1. Okay, so let's start building our LCD. Make these fractions, put them over 1. Actually, the new stuff I'm going to write in red. So 1 by 1. So let's build our LCD over here. So our denominators, this can't be factored. 1 obviously can't be factored. 1 can't be factored. X minus 1 cannot be factored either. So these examples don't have any factoring involved, which isn't too helpful. But if you get ones that factor, then factor them out. So ones don't count because 1 times anything is the same thing again. So your LCD is actually this x part and this x minus 1. So an x and an x minus 1. So here we go. So this side you're going to multiply by x times x minus 1. This side you're going to multiply by x times x minus 1. Okay, so now you're going to distribute this to this. Remember, this bottom part will go away with this x. So you're going to get a 2 times x minus 1 minus a 3 times x minus 1. That's what that is. Just put a 3 in the front. The bottom, this 1 doesn't really cancel with anything. So this is still your numerator. So I'll do the denominator in blue. This times this, nothing cancels because you have a 1 here. So it's going to be x times x minus 1. This and this is going to be in minus because it's that. So the x minus 1 and the x minus 1 right here will go away. 1 times x is an x. Now, since we still have all these minus signs going on, which should not, there shouldn't be any minus signs unless they're part of a group. So let's go ahead and, you know what? Here's a nice little factoring part. You can multiply all this out and then factor it back apart. But I spy with my little eye a common factor right here. So you can actually pull that out. I don't know if I want to show it that way because I'm pretty sure that might confuse a lot of students. So let me show this 2 ways. Just in case you don't spot that, you would multiply all this out. So it'd be a 2x minus a 2 minus a 3x squared plus a 3. You would have to combine all these together, so negative 3x squared plus a 2x plus a 1. Now, then you'd have to factor this thing because it's an x squared and you got to see if it has any common factors. So what I'm saying right now is that you can actually find a common factor right here that you can pull out. Okay, that's a common factor of x minus 1. Now the leftover parts are this 2 and this minus 3x. So you got a 2 minus a 3x. So that's actually factored. That's the top divided by. And same thing here, you actually have common factors here that you can pull out. So you can pull out an x. Leftovers are this x minus 1, and actually this is x times 1. So you have a 1 left over too. So that'll be x. Let's see here. Pull out x. That'll leave a x minus 1 minus a 1, basically, because this x came out right here. So let's see here. Now we have, I did something strange. Let's figure out what I did. X minus 1, x, pulled an x out. Left over x minus 2. I guess that's it. Okay, I guess I didn't do anything wrong. So that's going to be x minus 1 times a 2 minus 3x all over x times x minus 2. Okay, and I think that's the right answer. Let me double check. 2x minus 2 minus 3x x minus. Yeah, that's right. Okay, I thought I messed up because nothing canceled, but I was wrong. There you go. That's your answer right there. Some teachers want you to multiply out the top and multiply out the bottom, but you don't. I mean, depends on your teacher. So just ask them, do you want it in standard form or factored form? And you're done. One thing that students mess up on, sometimes they'll take this x and cancel it with this x, but remember these grouping symbols mean this is all one big term. So unless you have another group that matches this entire group, you don't mess with them. You don't mess with the groups, okay? If there was an x minus 1 group down here, then you can cancel that, but you can't pick apart a small piece of a group, okay? And that's it. All right, so if you have any questions, feel free to comment, and then I'll try to answer them if I can. Okay, bye-bye.